Good morning, students. Today's topic is complex numbers. It is very important for any competitive examination. Now, if suppose a number in the form of x plus iy, a number in the form of x plus iy, where x comma y are real numbers, and I equals to root of minus 1, I equals to root of minus 1 is called a complex number, The expression x plus iy, where x comma belongs to R and I equals to root minus 1 is called a complex number. Okay. Now here I is called real part, y is called imaginary part. In x plus iy, x is called real part and y is called imaginary part of the complex number. Now, if suppose if x equals to 0, then the complex number x plus iy, is called purely imaginary. If x equals to 0, then the complex number is called purely imaginary. And y equals to 0, then the complex number is called purely real. Next, always the complex number x plus iy, it is denoted by z. The complex number x plus iy always denoted z. Next, if suppose the two complex numbers, if suppose z1 equals to x plus iy, another complex number z2 equals to x minus, just a minute, a plus ib, z1 equals to x plus iy, z2 equals to a plus ib. If z1 equals to z2, z1 and z2, the two complex numbers are equal. The two complex numbers are equal. Means here x plus iy equals to a plus ib. Now it is defined only x equals to a, means real part of first complex number and real part of second complex number must be equal, and imaginary part of first complex number and second complex number also must be equal. Only in that case the two complex numbers are equal, otherwise we cannot say the complex numbers. Next, if suppose Z1 greater than Z2, first complex number greater than second complex number, means x plus iy is greater than a plus ib, a plus ib. Now compulsory the imaginary parts must be 0, only it is defined, otherwise it is not defined. Means y equals to 0, b equals to 0 and x greater than a, only it is defined, otherwise it is not defined, If suppose similarly z1 less than z2, means x plus iy less than a plus ib, it is defined compulsory the imaginary parts must be 0, means y equals to 0 and b equals to also must be 0. Imaginary parts must be 0, only it is defined, the inequality defined, and x must be less than a, then z1 is less than z2, If suppose z1 equals to x plus iy, z2 equals to a plus ib are two complex numbers. z1 equals to x plus iy, z2 equals to a plus ib are two complex numbers. Now the addition of two complex numbers z1 plus z2 is defined by now x plus iy plus a plus ib. Now that equals to x plus a plus I of y plus b, means first add only real parts plus I into imaginary parts. Similarly z1 minus z2 equals to x plus iy minus of a plus ib, that equals to x minus a plus I of y minus b, Next, if suppose here in this chapter always I equals to square root of minus 1, I is also called iota. I is called iota also. Now I equals to root of minus 1. Now squaring on both sides, I square equals to minus 1. Next I cube equals to minus I, because I cube can be written as I square into I, that equals to, but I square equals to minus 1, that equals to we get minus I cube equals to minus I. Next I to the power of 4 equals to I square into I square, that equals to minus 1 into minus 1, because the value of I square equals to minus 1, that equals to 1. Means if suppose the exponent of I is multiple of 4, always its value equals to 1. Now always sum of, if suppose the exponents of I 1, 2, 3, 4, means consecutive 4 integers, consecutive 4 integers, then always their sum equals to 0. I plus I square plus I cube plus I to the power of 4. It always equals to 0 because the value of I square equals to minus 1, I cube equals to minus I to the power of 4 equals to 1. Now its value equals to always 0. Its value equals to 0. For example, find the value of I plus I square plus I cube plus up to so on I to the power of 100, I to the power of 100. Now see it, always if suppose I plus I square plus I cube plus I to the power of 4, it is equals to 0, equals to 0. Similarly, I to the power of 5 plus I to the power of 6 plus I to the power of 7 plus I to the power of 8. Here I to the power of 5 can be written as I to the power of 4 into I plus I to the power of 6 equals to I to the power of 4 into I square plus I to the power of 7 equals to I to the power of 4 into I cube plus I to the power of 8 can be written as I to the power of 4 into I to the power of 4. Now, but I to the power of 4 equals to 1. 1 into I plus I to the power of 4 into I square, but I to the power of 4 always 1 plus I square plus I cube plus I to the power of 4. Again it is 0. Means every 4 consecutive terms sum, the sum of 4 consecutive terms is 0. Now here I to the power of 100, I to the power of 100, it is nothing but 25 groups of like this. First I plus I square plus I cube plus I to the power of 4, one group. Next I to the power of 5 plus I to the power of 6 plus I to the power of 7 plus I to the power of 8, second group. Next group, similarly I to the power of 9 plus I to the power of 10 plus I to the power of 11 plus I to the power of 12. It is one group. It is also equals to 0. Like that we get 25 groups. Now all groups, each group equals to, in 25 groups, in each group equals to 0. Therefore the value is 0. It is equals to 0. Next, conjugate complex number. Conjugate complex number. If suppose a complex number z equals to x plus iy, a complex number z equals to x plus iy. Now another conjugate number z bar equals to x minus iy. If suppose the sum and product of two complex numbers is a real, sum of the complex number is a real number and their product also real number, then both are conjugate to each other. If suppose z equals to x plus iy and z bar equals to x minus iy, because always z is a complex number, its conjugate denoted by z bar equals to x minus iy. Now what is the value of z plus z bar equals to, adding these two, now x plus iy plus x minus iy, that equals to 2x. Similarly z into z bar equals to x plus iy into x minus iy, x plus iy into x minus iy, that equals to a plus b into a minus b, x square minus iy whole square, that equals to x square minus I square y square, but the value of I square equals to minus 1, then we get x square plus y square. Now 2x is real number, 2x is also real number, x belongs to real number, 2x also belongs to real number. Next y also real number, because the complex number x plus iy, in that x and y both are real numbers, x and y both are real numbers. Now 2x is real number, x square plus y square also belongs to real numbers. Now the sum and product of two complex numbers is a real, then the two complex numbers are said to be conjugate to each other, conjugate to each other. If one complex number x plus iy and its conjugate complex number, it is denoted by z bar and it is equals to x minus iy, x minus iy, x plus iy and x minus iy are both are conjugate to each other, or conjugate complex numbers. Next, find, just a minute, if 2 plus I by 2 plus 3i equals to a plus ib, then find the values of a and b. A and B. Now, here given 2 plus I by 2 plus 3I equals to A plus IB, A plus IB. Now, require the values of A and B, require the values of A and B. Now, see it. First to take only left side 2 plus I by 2 plus 3I. What is the conjugate of 2 plus 3I? 2 plus 3i conjugate is 2 minus 3i. It is multiply and divide it. 2 minus 3i by 2 minus 3i. It is same as equals to a plus ib. That equals to, now multiply together 4 minus 6i plus 2i minus 3i square by a plus b into a minus b, 2 square minus 3i whole square, that equals to a plus ib, equals to a plus ib. Now numerator 4 minus 6i plus 2i minus 4i, here I square equals to minus 1, I square equals to minus 1, minus of minus plus 3 by 4 minus 3 whole square, 9 I square, that equals to a plus ib. Now 4 plus 3, 7 minus 4i by 4 I square equals to minus 1, minus of minus plus 9, that equals to a plus ib, a plus ib. Now 7 minus 4i by 4 plus 9, 13 equals to a plus ib. Split it, we get 7 by 13 plus minus 4 by 13 4 by 13 of I equals to a plus ib, a plus ib. Therefore, the value of a equals to 7 by 13, comma b equals to minus 4 by 13. A equals to 7 by 13, B equals to minus 4 by 13. Next, if suppose two complex numbers, one is Z1, second is Z2. If suppose Z1 square plus Z2 square, it is not always positive, it may be negative or imaginary also. Now see it. For example, or it is also 0. First let Z1 equals to 1 plus I and Z2 equals to 1 minus I, take it. Z1 equals to 1 plus I, Z2 equals to 1 minus I. Now Z1 square equals to 1 plus I whole square, that equals to 1 plus I square plus 2I, or that equals to 1, I square equals to minus 1 plus 2I, that equals to 2I. Next to Z2 equals to 1 minus I, Z2 square equals to 1 minus I whole square, or that equals to 1 plus I square minus 2I. A minus B whole square equals to A square plus B square minus 2AB, that equals to 1, I square equals to minus 1 minus 2I, minus 1 plus 1 cancel, that equals to minus 2I. Therefore, here Z1 square equals to, here Z1 square equals to 2I, Z2 square equals to minus 2I, Z1 square plus Z2 square equals to 2I minus 2I, that equals to, we get 0. But in real numbers, here Z1 square is positive, Z2 square is positive, sum of two positive quantities never 0. But in complex numbers it may be 0 or complex number we get. Next, find the square root of x plus iy. Find the square root of the complex number x plus iy. Find the square root of x plus iy. Now first let square root of x plus iy equals to some a plus ib. Here x, y, a and b are real numbers, where x, y, a and b belongs to real number set, real numbers, not imaginary numbers. The coefficients of complex numbers always real. Now here squaring on both sides, we get x plus iy equals to a plus ib whole square, a plus ib whole square. In right side, a plus ib whole square equals to a plus b whole square form a square plus ib whole square plus 2a into ib. Now x plus iy equals to a square, I square, b square, but I square equals to minus 1 minus b square plus 2abi, 2abi. Now right side also it is in the form of x plus iy. If suppose the two complex numbers are equal, then real parts must be equal and imaginary parts also equal. Now equating real and imaginary parts, on both sides. Now a square minus b square equals to x, it is considered equation 1. Real part a square minus b square equals to x. Next to 2ab equals to y, imaginary part. Now from these two equations we require the values of a and b, Now a square minus b square equals to x, a square plus b square whole square equals to a plus b whole square equals to a minus b whole square, or a square minus b square whole square plus 4a square b square, okay, because a minus b whole square equals to a square plus b square minus 2ab plus 4ab, add and subtract, then we get a square minus b square whole square minus 4a square b square, that is equals to a square plus b square whole square. But a square minus b square equals to x square plus 4a square b square, it is nothing but 2ab whole square plus y square. Now a square plus b square equals to plus or minus root of x square plus y square, plus or minus of x square plus y square, plus or minus square root of x square plus y square. But here a and b are belongs to real numbers, then a square plus b square must be positive quantity. Therefore here only a square plus b square equals to only square root of x square plus y square, because negative value not defined, because sum of squares of two real numbers, sum of squares of any two real numbers must be positive quantity. Now it is considered third equation 3. Now from first equation and third equation, 1 plus 3, first and third, add it, we get how much? A square minus b square equals to x, a square plus b square equals to square root of x square plus y square. Now a square minus b square plus a square plus b square equals to square root of x square plus y square plus x. Add these two, square root of a square plus x square plus x. Now minus b square plus b square cancel, 2a square equals to square root of x square plus y square plus x. A square equals to square root of x square plus y square plus x by 2, for implies a equals to plus or minus under root of x square plus y square plus x by 2. It may be plus sign or minus sign, positive real number or negative real number. A equals to, it may be plus or minus. Next, similarly, from third equation subtract first equation. What is third equation? A square plus b square minus of first equation a square minus b square, equals to square root of x square plus y square minus x. Now here plus a square minus a square get cancel, minus of minus plus b square, 2b square equals to square root of x square plus y square minus x. Now b square equals to square root of x square plus y square minus x by 2. Therefore b equals to square root of x square plus y square minus x by 2 under root. It may be plus or minus sign. B equals to plus or minus of square root of x square plus y square minus x by 2. Okay. Next seat. But square root of x plus I by equals to a plus ib. It may be here the values of a, two values, plus a equals to plus square root of x square plus y square plus x by 2, or a equals to minus square root of x square plus y square plus x by 2. Similarly, b equals also two values, one is plus sign, other is minus sign. Now, when we get these values, now see it. Here y equals to 2ab. If y greater than 0, consider y is positive value, then in that case a less than 0, b less than 0, both are negative values, we get y is positive. Or a greater than 0, b also greater than 0, both are positive also, y greater than 0 we get, means both are negative, both are positive. Therefore, square root of x plus iy equals to a plus ib. Here first to take plus sign, both are positive values, then we get square root of x square plus y square plus x by 2 plus I into b value. In b positive value, square root of x square plus y square minus x by 2. Both are positive, a and b are positive, otherwise both are negative. In that case, we get minus of square root of x square plus y square plus x by 2 plus I into under root of x square plus y square minus x by 2. Now, both are positive, otherwise both are negative. Here minus sign outside, a minus, b also minus, means if suppose if y greater than 0, for implies square root of x plus iy equals to plus or minus of square root of x square plus y square plus x by 2 plus I into under root of square root of x square plus y square minus x by 2 if y greater than 0. Next, if suppose if y less than 0, y is negative value, but the value of y equals to 2ab. In that case, a and b, one is positive, other is negative. If a less than 0, b greater than 0, or a greater than 0, b less than 0, only it is possible. Y is negative value, y is negative. Now, in that case, the root of x plus iy equals to, first to take a is positive value, b negative value. A positive means under root of square root of x square plus y square plus x by 2. B is negative, minus I into square root of x square plus y square minus x by 2. Or if suppose a less than 0, minus square root of x square plus y square plus x by 2 plus but b is positive. I into square root of x square plus y square minus x by 2. Therefore, in that case square root of x plus iy equals to plus or minus square root of x square plus y square plus x by 2 minus I into under root of square root of x square plus y square minus x by 2. Means to depend on the value of y only, y greater than 0 or y less than 0. If y greater than 0, square root of x plus iy equals to plus or minus under root of square root of x square plus y square plus x by 2 plus I into square root of x square plus y square minus x by 2. If y less than 0, its value equals to plus or minus square root of x square plus y square plus x by 2 minus I into under root of square root of x square plus y square minus x by 2. Next means finally, if y greater than 0 for implies square root of x plus iy equals to plus or minus of square root of x square plus y square plus x by 2 complete square root plus I into square root of x square plus y square minus x by 2. If y less than 0 for implies square root of x plus iy equals to plus or minus of under root of x square plus y square plus x by 2 minus I into under root of square root of x square plus y square minus x by 2. These are the values. Also here z equals to x plus iy for implies mod z equals to modulus of a function, it is equals to square root of x square plus y square. Now it is also can be written as equals to plus or minus under root of mod z plus x plus x by 2 plus I into square root of mod z minus x by 2. Similarly, y less than 0, that equals to plus or minus square root of mod z plus x by 2 minus I into square root of mod z minus x by 2. Okay. Now it is square root of any complex number. Now some problems. Example, find the square root of 3 plus 4i, 3 plus 4i. Now here what is square root of x plus iy? Here x equals to, here required square root of 3 plus 4i, 3 plus 4i. Here x equals to 4, sorry, x equals to 3, x equals to 3, y equals to 4. Now y greater than 0, y greater than 0, then square root of x plus iy equals to plus or minus square root of mod z plus x by 2 plus I into square root of mod z minus x by 2, mod z minus x by 2. But here mod z equals to root of x square plus y square, root of x square plus y square, or that equals to square root of 9 plus 16, that equals to 5. Therefore square root of 3 plus 4i, 3 plus 4i equals to plus or minus of square root of mod z equals to how much? 5 plus x equals to 3 by 2 plus I into square root of mod z equals to 5 minus 3 by 2, or that equals to plus or minus of under root of 8 by 2 plus I into under root of 2 by 2, or that equals to plus or minus of, now 2 4 times cancel, square root of 4 is 2 plus 2 to cancel I. Now that equals to plus or minus 2 plus I, plus or minus 2 plus I. Now the square root of 3 plus 4i equals to plus or minus 2 plus I. Next example, find the square root of I. Find the square root of I. Now here x plus iy equals to given I. It also can be written as 0 plus 1 into I, 1 into I, 1 into I. Now therefore equate x equals to 0, comma y equals to 1, y equals to 1, but y greater than 0, positive value. Now required square root of I. Next, what is mod z equals to, or square root of x square plus y square? Square root of x square plus y square equals to 1. Square root of x square plus y square equals to 1. Now therefore root I equals to plus or minus of under root of mod z plus x by 2 plus I into square root of mod z minus x by 2, that equals to plus or minus of under root of mod z equals to 1 plus x equals to 0 by 2 plus I into square root of mod z equals to 1, x equals to 0 by 2, or that equals to plus or minus of 1 by root 2 plus I into 1 by root 2, 1 by root 2 take common, that equals to plus or minus of 1 by root 2 into 1 plus I, 1 plus I. Now therefore square root of I equals to, square root of I equals to plus or minus 1 by root 2 of 1 plus I, 1 plus I. Next problem, if x plus iy whole cube equals to p plus iq. Then find the value of p by x plus q by y in terms of x and y. Find the value of p by x plus q by y in terms of y. Now, here given x plus iy whole cube equals to p plus iq. Given x plus iy whole cube equals to p plus iq. Now, left side a plus b whole cube formula, that equals to x cube plus iy whole cube plus 3 into x square into iy plus 3x into iy whole square, that equals to p plus iq given. Now x cube. Now I cube equals to I square into I, but I square equals to minus 1, that equals to minus I. Therefore I cube y cube equals to minus yi, because I cube equals to y cube I. Next to plus 3x square yi. Here I square equals to minus 1, that equals to minus 3xy, that equals to p plus iq. Now x cube minus 3xy means real part. Next to, in these two terms I take common, plus I of 3x square by minus y cube equals to p plus iq. Now equate real parts on both sides. Real parts, x cube minus 3xy equals to p, and imaginary parts also equate 3x square y minus y cube equals to q. Now here x cube plus 3xy equals to p. X take common, x square minus 3y equals to p. Now p by x equals to here y square. P by x equals to x square minus 3y square. Next to, in left side y take common, 3x square minus y square equals to q. Now q by y equals to 3x square minus y square. Here it is considered 1, 2. But require the value p by x plus q by y. P by x plus q by y equals to p by x plus q by y. P by x equals to x square minus 3y square plus q by y equals to 3x square minus y square, or that equals to 4x square minus 4y square, or that equals to 4 of x square minus y square. Therefore p by x plus q by y equals to 4 of x square minus y square. Next example, if 1 plus I by 1 minus I is 1 minus I by 1 plus I equals to x plus iy. Then find the values of x and y. Find the values of x and y. Now the given 1 plus I by 1 minus I equals to 1 minus I by 1 plus I. Plus equals to x plus iy given. Okay. Now take LCM. What is LCM? 1 minus I into 1 plus I. LCM. Numerator 1 plus I whole square plus 1 minus I whole square. That equals to given x plus iy. X plus iy. Now 1 plus I whole square, a plus b whole square, a plus b whole square. Now that equals to, we get 1 plus I square plus 2i plus 1 plus I square minus 2i, a minus b whole square. By denominator a minus b into a plus b, 1 minus I square, a square minus b square. That equals to x plus iy. Now for implies 1 I square equals to minus 1 plus 2i minus 2i get cancelled plus 1 I square equals to minus 1 by 1 minus I square equals to plus 1. That equals to x plus iy. X plus iy. Now numerator 1 minus 1 plus 1 minus 1, 0 by 2 equals to x plus iy. Therefore 0 by something equals to 0. X plus iy equals to 0. 0 nothing but 0 into I into 0. Now equate real and imaginary parts. Therefore x equals to 0, comma y equals to also 0. X equals to 0 and y equals to also 0. Okay, thank you very much. Tomorrow continue the same topic.